Hi everyone, we'll be waiting 2 to 3 minutes before starting the webinar to accommodate for the rest of the attendees who are in the middle of connecting. Welcome everyone. Thanks for joining us and thanks for being part of our community. My name is Valen Kolika and I'll be your host for today. Thank you for your participation and just a few reminders before we start with the presentation. If you have issues doing the stream at any time during the presentation and are using the web browser version of Teams, please refresh your browser. If you're using the desktop app of Teams, please exit and rejoin. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. Closed captions are available during the live broadcast. You can enable it by clicking on the CC button located at the lower right corner of your screen. Now, during this time, please feel free to ask questions at any time by typing them in the live event Q&A window, and you can click on the Ask a Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right next where you entered it. We often get many questions on these webinars, and we'll do our best to respond to all. In the event, if the answer was not provided, or if you may have additional questions post this event, please don't hesitate to raise them on our Azure Security Center forum at aka.ms/ASC community. If you're listening to this after the fact as a recording, that's also a great place to ask a question. Now, we love to hear your feedback on how we can improve these webinars, and you can do so at aka.ms/security-webinar-feedback. And while you're there, please join our community by visiting aka.ms/security-community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You will be able to influence our product designs and get early access to changes by doing things like participating in private previews, which you can sign up for at aka.ms/security private preview. And while you're there, you can request features, you can give feedback, review our product roadmaps, attend in-person events, or join webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. In today's session, Aviv will guide us through a VM automation with the Azure Security Center. Aviv Morris is a senior program manager with our Azure Security Center team. And without further ado, I'll turn it over to him. Aviv, the floor is yours.
Thank you, Valen. Thanks for the introduction. I hope you can see me and hear me. It's already dark here in Israel. So thanks everyone for joining. My name is Aviv Mo. I'm a program manager at Azure Security Center product management team as part of the team that deals with cloud workload protection. And this session, we're going to talk about how to protect your VMs in Azure and also in your multi-cloud platforms. And this is the agenda for today. We're going to basically cover our offering that is called Azure Defender for servers. We're going to talk about the main capabilities and see some demos. And before we dive into it, let's talk a little bit about challenges. You always have to start with the challenges, right? So just as a recap for what we're trying to deal with, so as you know, with working with the cloud workloads, there is the challenge of rapidly changing resources. It's hard to keep track of what your organization IT infrastructure looks like. Of course, there's the challenge of shadow IT. So with although people are empowered to do more and keep with the pace of business and keep growing and scaling up the IT infrastructures, there's the challenge of keeping track on all of that and maintaining security standards across all of your dynamic workloads. Of course, attacks are becoming more and more sophisticated, and they adapt to the changing IT infrastructure as well. And of course, as always, security teams are not growing linearly with the size of business. So there's always a challenge of maintaining skill and the size of the teams to combat all of these threats and attacks. And with Azure Security Center, we address these challenges. We just recently, at this year's Ignite, we announced our Azure Defender offering, which is formerly what was called as Azure Security Center Standard Tier. You have Azure Defender for different types of resources like key vaults, SQL servers, Kubernetes clusters, etc., etc. Today, we're going to talk about the Azure Defender for servers, which is our offering for protecting your VM workloads. And in order to do that, we'll have to first look on what types of threats or paradigms we apply in this offering. So we're going to cover several points today. And Azure Defender for servers is a multi-layered approach for protecting VMs against different threats. You will see that it combines methods for minimizing the attack surface, as well as detecting and preventing threats in real time that take place on your VMs. So we're going to cover how you onboard servers to Azure Defender, and starting with simple and basic server hygiene, and going up to more methods of protection like file integrity monitoring, detecting advanced threats, and more. So as a beginning, when you enable Azure Defender for servers on a subscription level, onboarding is automatic. There is an automatic deployment of our agent, log analytics agent, that collects a lot of information and logs from your servers for multiple purposes of later analysis of the security threats and the attacks that take place on the VMs. So we started this with Azure, and we recently announced that we also support automatic onboarding for AWS. workloads as well. So this is cool, a new announcement. We will see it. We will talk about it in the recap. And then going up the ladder of what we do with Azure Defender for servers, it starts with your security hygiene for servers. We're talking about dozens of different assessments that continuously run on your VMs and advise you to improve your security posture and address security best practices. To take some examples on that, we look on the state of your patch. It will do a patch assessment on your VMs and recommend on patches to be installed on your VMs, and will recommend on security baselines like best recommendations for OS security configurations. So this is one container of multiple assessments that will drive your security posture of your VMs. When you see that hybrid ribbon at the side of the slide, it means that we support that not only for Azure resources, but also for on-premise and multi-cloud workloads. So that's one part of what we do in Azure Defender. Second is, and we're going up the ladder, is vulnerability scanning. So here we want to minimize the attack surface by floating and recommending and showing vulnerable apps that are installed on your VMs. So there are several ways to do vulnerability assessment for your VMs, but one of them, the one that we will cover today, would be the embedded vulnerability scanner that we have in Azure Defender for servers. It is powered by Qualys. So it's a deep integration that we've developed together with Qualys. In terms of licensing, it's included at no additional cost in Azure Defender for servers, and you can easily provision that agent to your VMs and get all the vulnerability findings at one consolidated place. We will see a demo of that shortly. You can provision that agent both manually and at scale. There are multiple ways to deploy that agent, from the simple UI methods to remediate specific VMs, or you can also use ARM templates, PowerShell scripts. You can use Azure Policy for that, Logic apps, REST APIs. So there are multiple ways to manage the provisioning of that agent. It supports Windows and Linux machines, very wide OS support. And you can consume the findings centrally within ASC. We'll also see a couple of examples on how to do that manually and at scale. We also recently announced that it is supported on Azure Arc machines as well, which allows you to deploy that agent on your on-premise and multi-cloud VMs as well. So basically, you can use the embedded vulnerability scanner to monitor all of your enterprise servers through Azure Security Center. So with that, we'll jump to a quick demo of that. Oops, sorry. Okay, so this is the dashboard for Azure Azure Defender. Here we see the main capabilities across different bundles. So with VMs, we see here the vulnerability assessment recommendations. And this is a recommendation that monitors our provisioning state for the vulnerability scanner. So we can see VMs that are already deployed with the embedded vulnerability scanner. You can see that it's a mixed environment here. We have Azure VMs as well as machines outside Azure, Azure Arc machines. And Deploying an agent through the API is as simple as selecting the VMs you want to remediate and then requesting to deploy the embedded scanner on them. So I'm selecting here an on-prem machine and a machine on AWS. And we can install the vulnerability scanner on them. So shortly after that, deployment typically takes a few minutes, and then the agent starts to scan the machine for all of its applications and configurations. And it would do that scan every 4 hours. And the results would end up here in the second assessment called vulnerabilities in your virtual machines should be remediated. And here I'm seeing all of my VMs that have some vulnerabilities. Again, we have here Azure as well as non-Azure machines. And we can either pivot by the vulnerability finding. So we can pick a specific finding and see to which VMs or machines it applies, as well as rich explanations on the nature of this specific vulnerability and how you can remediate it. And you can also pivot to a specific VM. So you can click on a specific machine or VM and then see all of its findings. So that's doing it for specific purposes of checking specific findings or VMs. But you can also work with that data at scale using for example, Azure Resource Graph. So that data is available programmatically as well. And you can craft your own queries to slice and dice the data the way that you want and consume it through Azure Resource Graph. And then you can either make reports, alerts, automations. So that's very, very flexible according to the use case. Another thing I want to show you is the ability to create your own dashboards to show the state of vulnerabilities across your different workloads. So this is a sample dashboard that is shared through our community. You can find it in our GitHub community. We can post the link for that in the chat. And this is an example on how you can use dashboards to see the vulnerabilities across your network. So you can hone in on specific severity of findings. You can have a view by a resource group, or focus on a specific resource. So that's another thing that you can do. Another thing that I wanted to show you is the ability to also continuously export the vulnerability findings. So we showed how it can be consumed through Azure Resource Graph, and we can also build dashboards based on Azure Monitor. But we can also use the continuous export feature, which we also recently released, in order to export the vulnerability findings on a continuous basis, either to Log Analytics Workspace or Event Hub. So to do that, we'll go to Pricing and Settings, select our subscription, and then choose Continuous Export. It's important to say that continuous export is supported across many recommendations, vulnerability findings included. But we can specifically pick this one and include security findings in order to show the specific findings in the assessment, and then choose whether we want to we can configure it for an Event Hub or Log Analytics Workspace, and then it will be automatically exported to that. So that basically allows you to leverage the data the way that you want. So you can use Azure Defender for servers to centrally deploy and use the embedded license across your Azure and non-Azure resources, and then centrally consume the vulnerability findings through reports, custom dashboards, and by that, centralize your vulnerability management program around ASC. So that summarizes the embedded vulnerability scanner inside the ASC. Another thing I want to talk about is file integrity monitoring. It's another capability that's included within Azure Defender for servers. The idea here is to monitor changes across important OS files or registry for Windows machines, although it supports both Windows and Linux machines. So it will continuously monitor critical OS files for changes and also registry keys, and that could indicate an attack that took place on a VM. You can also customize the policies in which you use the file integrity monitoring for. So that's another aspect of keeping a server hygiene and getting alerts on indications for attacks. And now we're going up the ladder to detection capabilities. So the detection aspect in Azure Security Center is comprised of two main sources. The first would be the embedded EDR solution, what was formerly called Microsoft Defender ATP. Now it is called the Microsoft Defender for Endpoints. So it's included within the Azure Defender for Servers license, and it's automatically provisioned to supported operating systems. Currently, we support Windows Server versions, and we intend, on our roadmap, we intend to support Linux servers as well as part of these integrations. And that's one aspect. You have built in within that license at no additional cost, Microsoft Defender for, which is very cool. The second aspect would be tailored analytics and alerts that we've created inside Azure Security Center for server attacks. So it primarily focuses on the Linux landscape, and you, as part of that, you get specific alerts for different types of attacks that we detect within ASC. So to summarize that, the detection part is combined of the embedded or built-in and integrated Microsoft Defender for endpoints that you can deploy on your workloads, as well as additional and complementary detections that we've added specifically for cloud attacks. It's also important to mention that the integration with the Defender for endpoints, it's reflected in two places. So first is the ability to see Defender alerts, Defender for endpoint alerts within Azure Security Center. So alerts are reflected in Azure Security Center, but you also have access to Microsoft Defender for endpoints portal as part of this integration. So you can investigate on the Defender for endpoint portal as well if you want to dive deeply into a specific attack or a machine. Okay, so the next feature that we are going to talk about is the adaptive application controls. This is a capability that we've developed inside Azure Security Center in order to monitor the behaviors and basically the process behavior activity of your VMs. And it allows you to define a policy of allowed processes, the processes that are allowed to run in your VMs. Now, how do you get to that list? We have many workloads, different applications running. It's not an easy task to define which applications are allowed to run on every server. So In adaptive application controls, we give you an automatic recommendations based on a continuous analysis of your VM activity. We give a recommendation that shows you the applications that should be allowed to run on your servers. So let's talk about how adaptive application works. It analyzes all of your VMs, and it looks on their process activity, and it starts to build a baseline. It builds the baseline for about 2 weeks, and after 2 weeks, if there is a baseline that we can recommend on, we will float a recommendation for that VM with the applications and certificate publishers we think that should be allowed to run on this machine. It's important to say here as well that we group those recommendations into VM groups. So if there are several VMs that show similar behavior in terms of process activity, we will automatically cluster them into one group to make it more easy for you to manage those policies. So after you've activated this recommendation and added your VMs to that group, Azure Security Center will monitor the activity on those VMs from that point, and then we'll send you alerts on deviations from that baseline. So it basically automates almost the whole process of getting to know your VMs better in terms of process activity and monitoring that activity or baseline is being kept across time. Now, you may ask yourself, what happens if the activity changes because of version upgrades or other applicative changes that may change the process activity as well? So we also recently released a new type of recommendation that continuously updates the recommended apps for monitoring. So if we see a deviation in the baseline of the VM, we will show it in a specific recommendation that would basically tell you, hey, we see this new activity and we think it should be added to the allow list of applications. So you also get that, so you can continuously make sure that your baseline is adapted to what your servers are doing. And with that, we can jump for a quick demo. Okay, so starting again with Azure Defender for Servers dashboard. Sorry, Azure Defender dashboard. And here we see a link to adaptive application controls. So we see here different types of machines. No recommendation would be VMs that either don't have an agent on them or that don't have a clear baseline that we can recommend on. And here we see the VMs that are already configured and monitored, meaning that when it says auditing, it means that if there is a strong deviation from baseline, which may be caused by an attack, an alert would be generated. And this group is the VM that we are recommending to onboard to the policy. So we see a clear baseline, and we recommend you to audit that baseline. So if we pick an example group, we can see the VMs that we've clustered together with similar activity. It goes from top to bottom. It starts with certificate publishers. So you can centrally allow everything Microsoft or everything signed by Qualys. So you don't have to deal with specific processes. But also for unsigned processes, we can recommend on specific path rules to audit. And once we've enabled that, it will create that group and then start monitoring it for changes. Now, we mentioned the alerts being generated on deviations. So if we go to the security alerts, this is where we see all the alerts that are generated by Azure Security Center. We can also see alerts generated by adaptive application controls. So we see that in that case, a policy violation was audited. And then we can dive into the details of what changed. we can see the VM, the file that was executed, and then decide what kind of action we want to take. Important to say that we've added a new logic app here. So in some cases, you may say, I know that file, it's okay. I want to add it to the allow list. So we recently added a logic app to automatically do that. You can find it in the in our GitHub community, and I believe we will share that link for that new logic app also in the chat. So in terms of response, you can also decide to add it to your allow list if you think this is a legitimate app. But otherwise, you may find here unwanted processes that may have been executed as part of an attack. So that covers adaptive application controls. And the last piece of what you get as part of the VM protection is the cloud native controls. It's comprised of two parts. One part is what we call adaptive network hardening, which is very similar to adaptive application control, but on the networking side. Adaptive network hardening looks on the communications that were allowed for the VM. So for example, you may have open specific ports in your NSGs and firewalls, but you are utilizing less than that. So adaptive network hardening can say, hey, we think there are some unnecessary open ports in your configuration because you don't use them much. So that can help you review your networking rules and optionally remove unused open ports to further harden your network configuration. On the other hand, it can also generate alerts on anomalies in the network activity. So as part of an attack, you may have been communicating with an IP address that we know as part of our threat intelligence feeds, or just an IP address that doesn't usually communicate with you and has shown some abnormal activity with your VMs, and that may trigger an alert. So adaptive network hardening can generate alerts on suspicious activity, as well as recommend you to harden your network configuration and close unused ports. The second part of the cloud native controls is the just-in-time VM access, which helps you deal with the attack surface around management ports. So typically, we have had open management ports open to I don't know, pre-configured IP addresses or subnets that we use to connect to our servers, but that is an unnecessary attack surface. And with JIT, we allow you to open management ports just per need. So just when you need to connect to your VM, we can help you or automate the process of opening the management ports to specific IP addresses. And we're going to see a demo for that as well. So let's jump to JIT. Okay. So typically, this is what you would see, right? You would have a VM. It's opened to the wide web with a management port, and you can download an RDP file and then connect. You don't see that screen, and then connect to that VM. But also, many other people can connect to it as well, right? So with Security Center, what we do is let's start from the beginning here. So we scan all of your VM's networking configuration. So we look on the NIC, on the NSGs, on the firewalls around your VMs. And we assess whether there is an open path of management ports to your VMs. And if there is such an open path by your previously configured rules, we will recommend to onboard those VMs to JIT. So here we see a list of VMs already onboarded to just-in-time network access, as well as VMs that are not onboarded to JIT. You can see some of them are healthy and some of them are not. The healthy ones are ones that don't have management ports exposed. Maybe someone puts a specific rule that would block these ports, and so there's no real problem. So so at that point of time, you don't need JIT protection. But other ones do have management ports exposed to the internet, and then you can onboard them to JIT. So that's a one-time operation per VM, where you can decide on the JIT policy that will be applied on them. So you can decide what ports you want to include or what ports you want to allow to have access for. And once someone requests access, how long should it be open? And then you can save that configuration, and shortly after, Azure Security Center will create the necessary firewall or NSG rules to continue to permanently block access to management ports. So that's the first part of just-in-time access. The second part would be, of course, requesting access to connect, right? So here we have a VM already protected by JIT. And you can see that when I ask to connect to this one, it looks differently, right? On a normal VM, it looks like that. You can just download the RDP file. Whoops, it's already been configured. But instead of just downloading the RDP file, you can request access. And what happens at that point is that you have the permissions to connect to that VM, that you are part of the people that are allowed to connect to that VM, but it also configures the necessary networking rules across NSGs, firewalls, whatever the network configuration is, to open a time-limited rule to be able to connect to it. So you can request access just for your IP address, or for someone else's IP address, or everything configured by the JIT policy that the VM was onboarded with. And shortly after that, it should be available to connect. Again, it jumped on the other screen, but here it is. The ports were just open at this second, and I can connect to my VM. Oops, sorry. Yeah. And after a certain amount of time, these rules will be removed, and in that case, the RDP port will not be exposed to any address in the internet. So that's a just-in-time access. I want to mention that in our GitHub community, there are a lot of automations of different kinds, PowerShell scripts, logic apps, and the different resources that you can utilize in order to automate some of your daily tasks with the ASC. So I highly encourage you to visit our GitHub community and have a look on the additional resources. We will be sending links to all of those in the end. So to summarize what we covered in this webinar. So with Azure Security Center, specifically Azure Defender for Servers, which we talked about today, you can protect your Azure VMs as well as your non-Azure VMs, and that's most of it is recent announcements that we've made in order to cover starting basic server hygiene and going up to advanced protection with features like adaptive application control, JIT, the integration, file integrity monitoring, and also use vulnerability scanning and Microsoft Defender for endpoints that are included within that offering in order to get advanced protection. I also want to encourage you to try it yourself. You can start with a free trial and play with that on your resources. And that's about it for now. So let's have a look at the chat.
Thank you, Lior. Yep. I'm going to announce here the Poll Everywhere link so the folks can directly ask you questions, and let me also share that here in just a second.
Sorry, I'm going to unshare my screen for a second. Okay.
We got some questions trickling in. Feel free when you're ready to tackle them.
Sure. An existing connection terminated with. Okay, so regarding the first question, it does not terminate existing connections. At the moment, it just doesn't allow new connections from the point the time frame has ended. We can use Windows Admin Center to onboard multiple Windows servers to Azure Defender, but how can we onboard multiple Linux servers to Azure Defender?
I'd actually just replied to this question on the chat. Basically, the way to do that is to make sure that Azure Arc is installed on the Linux servers. Once Azure Arc is there, from that point forward, the servers are basically connected to Azure, and as long as the auto provision setting in Azure Security Center is enabled, the Linux agent and the Windows Defender for Servers offering will be enabled.
Mm-hmm.
Thank you, Ben.
Okay, what else do we have here? Does File Integrity Monitor support file shares as well? As far as I remember, it does not. Ben, am I correct here? Okay,
yes.
We'll get the question. Okay. So at the moment, it does not support file shares. Can ASC also protect non-IaaS workloads? For example, AWS, looking for, yes, absolutely. So most of the capabilities that we've covered in this presentation are supporting multi-cloud workloads. So AWS included. Almost everything. So we're talking about the ability to use Defender for endpoints, the embedded vulnerability scanner, adaptive application controls, some of the detections, and in the shared presentation that you will see, it has that hybrid tag, and also in our documentation, we show the specific support for hybrid workloads. So the answer is absolutely yes. Specifically for AWS, we've also introduced a connector that helps you automatically onboard your AWS workloads to Azure Security Center. So it is almost the same native support with automatic onboarding. So you don't have to manually onboard new AWS servers. So there is a question about the pricing model. The pricing model remains the same with Azure Defender for servers. Okay. Will there be support to scan Power BI apps to check security and permissions, etc.? So currently, we don't support that. I don't have a specific plan to share on that. PIM integration is something that we're looking at. It's a scenario that we're currently looking at. We don't have specific timelines, but it is something that we are looking to work on. What else do we have? Does one have to pay? So the question regarding the OS support with Qualys, we are on par with the same operating systems that Qualys supports. So if it's stated as supported by Qualys, we will allow this. We will allow deployment to that VM, and even more than that. So the currently stated OS support list is the official support. It may work on peripheral distributions as well, but the ones that are officially supported by Qualys are also supported by Azure Security Center. Can you clear answered questions of the screen? That would help. Yes, that's a good idea. I will let Valonas answer this one.
Well, thank you. I mean, we answered most of the questions here, and the team behind the scenes took care of a bunch. Let me just stop sharing here, and we'll get back on track.
Yeah.
So just some reminders before we end the call. If you would like to follow us, to continue following us regarding the future webinars with our security products, please visit us at aka.ms/security webinars. And in case we missed to answer your question, or if you have additional questions, you can visit us on our Azure Security Center forum at aka.ms/ASC community. I would like to close this webinar by thanking Aviv for an awesome presentation. Thank you so much. And thank you to the rest of the team who help answering questions. And most of all, I want to thank all of you for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.
Yeah. Thanks everyone for joining. Have a great day.